Yes. Last time we anybody can tell me how much we have covered last time? Up to arithmetic instructions are over, or what was the status? Some data instructions. I think MBI we have done, LDA. Okay, LXI also. STA. STA we have done last time. Yes. I think it is done. Then in out also we have done addition. Addition ADI is also done. I think SUI. We started with the SUI. Subtract immediate from the accumulator. I will share PPT with you first. But before moving ahead, so a lot of students are asking me about this MST. So can we keep the syllabus up to how much we cover today? We will finish. We can finish with this instruction set today. That is for addition, arithmetic as well as for the logical instructions. So up to that much we can keep for the MST. Okay, Atharva. Then many are there. So is it okay? As per as the I'm audible or not? Kaveri, Shruti, Shubhangi, am I audible? Saloni, Varun.
Yes, sir, you're audible.
Yes, sir, you're audible.
So is it okay? So we will keep up to this instruction set. See, in that case, what will happen? We have low cost automation and this introductory part of the 8085. So as per the instructions from exam section, we'll be having 4 questions, 5 marks each. So that will be of 20 marks. So I will prepare some 3-4 set different question paper sets, and we can finish with that.
So what type of questions can we expect from 8085?
Okay, 8085. See, I will ask some question regarding selection of instructions. Instruction format is given to you. It is there in the slide PPT. Now, if that is the case, the process that process, how the data transfer takes place, that is also being given over there. So for particular applications, it will be there. I cannot tell you the exact question. So something similar will be there. You just go through all the instruction set. It should not be a much problem. For low cost automation, also it will be of more of application based. I cannot ask you to explain the say semi-automatic circuit, automatic circuit sequencing. So it is already there in your PPT. What you people I can expect from you. So the questions will be something where you are required to apply whatever the basic things you have studied, basic circuits you have studied.
So can you share some practice problems?
Practice, Harshal. uh, I can give some if available. See, actually, this particular thing we started mainly during this online examination. So I had to change a lot of as far as the paper pattern is concerned. Earlier, paper pattern was slightly different. Pattern means that type of questions. But now with this online, we cannot continue with the same setup. So type of question. So if it is available, I will forward to you people. Otherwise, you can be prepared with the diagrams that we have studied. Try to understand those diagrams. If someone asks you to slightly modify those diagrams with reference to particular application, you should be able to do that. That is something we are expecting. Okay.
Okay, sir.
Something is there. Just. All of you must have seen the video uploaded by Siddesh. So those students who were there in the lab today, so they, I think, almost except the Aditi's group and perhaps Sharvari. So almost all were able to do that. So even those who were not able to do in next session, everything will be understood. So this is you can enter the program. You can see the output.
So for the online class, like, isn't there any software where we can also practice?
No. See, simulators, some, but it is a slightly tedious process to download them, and it is not giving you the feel as such. Earlier, whenever it was totally online, that time also I had faced lot of issues with that because it is not fruitful. It it is not giving you exact idea. I just asked the student to prepare different programs. Nothing else was actually possible with that. So it is slightly difficult. So later on also I will share with you some videos. That is, and then you will be just preparing the programs in the notebook. That is something only possible after MST. For each of the turn, I will be having some small Viva kind of thing so that I can evaluate properly. Okay, so
Yes.
we can move. We can move ahead with this. Right now, you are observing subtract immediate from the accumulator. The meaning of this instruction is that you are trying to subtract the data, 8-bit data, directly from the content of accumulator. See, vice versa is not possible. That is, you cannot subtract accumulator content from the data given. The data given has to be subtracted from the accumulator content. That is the only possible thing, and that is what the format says. So something now example is given to you SUI05H. So this SUI05H means you want to subtract this 05H from the accumulator content. So for that the procedure is given. So for example, today some of you were able to directly do addition program, something like that. But the procedure that you people adopted, it is not a very appropriate procedure. So you people, Neha, I think Neha was there, and someone else, Siddesh. So don't access YouTube video or Google. You need to understand. See, in Google or whatever it is, they will directly give you the instruction or the procedure. But then, if you are not followed it with the manual, then how will you understand it later on? Now, altogether different program you need to do. So you should be knowing whatever is asked to you. You should be knowing the basic thing so that you can be adaptable to different conditions later on. So if you are directly going for these ready-made things, then it is difficult. Okay, so it is of no use because it is directly. This is what I told you people. This is a reverse engineering. So it is of no use. If the now application-based questions will be there, then you cannot justify those questions later on. So don't adopt that procedure of directly. Now you people are habitual. I think for last 2 years, accessing internet for everything. But for practical, at least at that point of time, restrict yourself to the manual and to the system which you are having. So here, so those who are coming next time for the physical session, so that time you can execute this same program which is indicated over here. That is, you can use the SUI instruction. Okay, so for example, accumulator is containing 8, 08. Then if you are exercising this instruction, then 05 will be deducted from it, and after execution 03 will be the content in the accumulator. So this output, so those who were there today, so you people have just stored that output at one particular memory location. Instead of, suppose you want to go it to the, you want to store at the accumulator only. So what actually is the difference? What is the methodology to retain over in the accumulator, or or to store at particular memory location, and then what is the procedure? So that is important to understand. If you are directly referring over there, then it is not going to be helpful. Later on, anyway, once your one turn is over, I will be giving you one standard procedure. With that standard procedure, anyway, you can have a very complicated program. But if you just follow that procedure, everything you can do it easily. But before that, at least I want you to try on your own. You will learn something, and then you can expedite it in the final session. And then these are other arithmetic instructions, that is increment or decrement. Increment means what? You are just moving to the next memory line. That's all, or you are adding one to already existing data byte. That is the increment. Decrement, exactly contrary. That is, you are deducting one, or you are getting back to the previous line. That is decrement. So you, at one step only, you are moving ahead or moving back. That is what. Now the instructions which are used for increment is INR. For decrement, the instruction or the key. Both the keys are directly available on the microprocessor kit. That is INR key as well as DCR key. You can directly use those keys and you can execute the program. What is the format for instruction? So for that, opcode will be INR, then operand will be RM. R means for register, for M for memory location. So suppose you are using the instruction INR B. Then in that case, INR B if you are using, then it means you want to increment the content of register B. So it will get incremented by 1. If INR M you are using, then INR M means what? You are incrementing the content at particular memory location. So this is something we can see before execution. Suppose 10 was the content, then that you have incremented, so it becomes 11. It will be stored at B because only B you are carrying it out. Then again similarly some memory location is there, that is 2050. You are incrementing it by 1, so it will get added 1. So this is a simple procedure for incrementing. Similarly, exactly opposite procedure is there for the decrementing. So that decrementing opcode DCR is there. So that you operand, that is R and M. So you can DCR B again if you are using, or DCR M. This is how the data content is there. That is before execution. Suppose 20 was the content for the register E. You are decrementing it by 1. So after execution it becomes 19. Similarly, before execution, that is 2050, you are getting it 21, then after execution getting 20. So this is a simple procedure for this increment and decrement functions in 8085. Then there are logical instructions. These instructions perform logical operations on data stored in the registers, memory, and status flag. So these logical operations are, say, you are using AND operation or OR operation. Now, some of you might be aware of this logic gates. If you have studied computers in 12th, then you might be familiar. If you are those who are coming to the lab, I will show you the setup for that. It is actually very simple setup. You can carry out a simple experiment over there. So as to understand, see these logic gates, why do we need? Because sometimes there is a requirement that some specific conditions you want to apply, and you want specific output out of that. So if there is something like these instructions are there, then what kind of arrangement will be there in actual industry or in real time? So for that, these conditions are there. So for some specific output, we are expecting that it should be there, and then how to arrange now. For example, pneumatic system consists of different valves and cylinders. So to get that specific output, how should be the arrangement? So that arrangement we can display with the help of setup. So obviously that day also we will shoot some video, and then we will upload for the students who are joining online, so that you will understand this logical instance. Now, what is this logical instance? What you are actually going to calculate with that? So it means any 8-bit data or the contents of register or memory location can logically have and operation or operation. How to do that? And again, the results stored in the accumulator. Now, the example they are taking over there, just go through that example. Let me just check it out. How many people are actually there? Vedant, you have put something over there, na? That simulator 805.
Yes, sir.
Yeah, yeah. It is there, but still lot of issues are there. You those who can do that, you can access over there. But certain instruction, if you are having manual, it gives you lot of other experience. For the time being, those who want to use that, they can use this simulator. I think one or two other simulators are also there. Anyway, Ayush is there. Ayush, Adesh, Aditi, Aditya Singh, Amar,
Yes, sir.
Yes,
Yes,
sir.
sir.
Anjali, Anushka, Arnav.
Yes, sir.
Yes,
Yes,
sir.
What?
sir.
Yeah, yeah. Any problem, Ayush? Every time some issues are there, Ayush or not? Ayush, Arya, Ashutosh, Atharva,
Yes, sir.
Ashutosh, Atharva, Bhagyashri, Bhushan.
Yes,
Yes,
sir.
sir.
Ashutosh is there or not? Chaitanya, Gufran, Guru Prasad,
Yes, sir.
Yes, sir.
Yes, sir.
Guru Prasad, Gufran,
Ye- Yes, sir.
Harshada, Harshal,
Yes,
Hemant,
sir. Yes, sir.
Yes, sir.
Yes, sir.
Hemant, Ritik,
Yes, sir. There.
Jaivir Singh, Kaustubh,
Yes, sir.
Kaveri Manas,
Yes, sir.
Yes.
Mounil, Mohammad Saif, Mrityunjay, Munda.
Present, sir.
Yes, sir. You called my name.
Yes, sir. Munish, Neha Korde, Neha Kurian,
Yes, sir.
Yes, sir.
Yes, sir.
Shan,
Yes, sir.
Nishan, Nivrutti, Omkar, Praful,
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Prajakta, Pratik, Preeti, Rahil,
Yes, sir.
Sir, Rahil present.
Yes, sir.
Rahul, Pancha, Rahul Yadav, Rakesh, Ravi Desai, Ravi
Yes,
Parmar,
sir. Present. Present, sir.
Ravi Desai, Ravi Parmar, okay. Ritvik, Sagar, Sakshi,
Sir, Rayan
Saloni,
present, sir.
Yes, sir.
Yes. Present, sir.
Here.
Sarang, Sharwari,
Yes, sir.
Shivpriya, Shlok, Shreyas,
Present, sir.
Sir.
Sir, Rayan present, sir.
no, Shayan or no, Shruti,
Yes,
Shubham,
sir.
Shubhangi,
Yes, sir.
Yes, sir.
Was.
Sudesh, Suraj, Tanmay,
Yes,
Varun,
sir. Yes, sir.
Vedant, Yash. Rahil, you said something lab.
Yes, sir. So I was not able to write the program. So like
Yeah, no, no.
I
So,
could write,
yeah.
I could store the values in some address, but sir, I don't know how to call them,
No, no.
how to
Okay.
load them.
Acha. No, no.
Ah,
But see, if you're okay. If you're able to write it at some location, that is okay. Now, accessing is a different thing. That unless we go through the entire programming, probably we may not be able to understand. But if you are able to load it at particular location, that is sufficient.
yes, I'm
We have
able to at that particular location, but I don't know how to call it.
yes, yes. So okay. There are different ways, but we have not started with the programming. So
Okay,
once
sir.
we start with that, so it is in the initial stage only. And the students who were there in the lab today, so actually they have done all these things. They have accessed it value as well as they have displayed also. It is easier because they are having manual. So in manual, all instructions are given. But these people are even actually they have directly referred this thing, YouTube and all those. So it is ready-made material over there. But otherwise, all these things are there in the manual. So this ANA, the instruction is for carrying out and operation. This ANA means what? The contents of accumulator are logically ANDed with the contents of register or memory. Now, what does it mean? It means ANAB or ANAM. Means what? We are ANDing the accumulator content with the register B. Okay. Can anybody explain this? What is mean by ANDing it with the register content or accumulator content? What actually we are expecting here? For that, we need to again. I think that day I have explained you logic gates truth table. Did I explain that logic gates truth table? If not, I will immediately type it over here. Anybody able to recall?
No, sir.
Okay, okay. I will write down over here. Okay, so this is. It looks like something this like this. So this is the we can say truth table for and operation. What it means, X and Y, these are the two inputs. Suppose these two inputs, you can imagine that these are two walls, and two walls are connected in some particular arrangement, and then you are expecting output from there. Now, what does this mean? If both the walls are off, that is X input is zero as well as Y is zero, you will be getting output as 0. Means suppose you are expecting the outstroke of the piston, that will not occur. But suppose X is 0, means one valve is off, another is on. That is Y is 1. Then in that case also you will not get the output, because you have connected in such a fashion over there that you will not get the output. Again, suppose X is 1, that is X is operating or it is giving input, Y is 0, still you are not getting the output. But if X and Y both are on, then you are getting the output. That is, you are getting the output as 1. So what it means, this is a function of AND gate. So what is the characteristic of AND? If both the inputs are on, then only you will get the output as on. Now this is something, this logic is applied while carrying out AND operation. It means what? In this case, what we have seen X and Y. So similarly, when you go for the arithmetic part, out of this X and Y, one will be accumulator. Say for example, X is accumulator, Y is anything. Y can be your register, it can be memory content, whatever it is. So Y will be another output. And with these two inputs, you will apply the rules of AND. It means for these two inputs, if 0 0 is there, output will be 0. If 0 1 is there, output is 0. If 1 0 input is there, output is 0. And if both are on, then output is on. So this logic is applied while doing the AND operation, while carrying out the AND operation. So you can see this AND operation now. You can see the before execution, suppose accumulator is containing AA, double A. AA is what? It is hexadecimal number. B is containing 0F. Okay, so these two inputs are there. You are logically ANDing to these two inputs. It means what? You will convert this AA into binary system. So what will be the equivalent of this binary system? That is 1010. Okay, 1010. Now I hope you people might have understood this last time also. I tried to explain 0F is another input. So for 0 it is 000. For F that is 15, number 15 it is. So how will you get that 15? That is 11114. 4 times 1 is there. Okay. All of you understood this conversion? That is double AA is converted into 1010, and this 0F is converted into 0 and 4 times 1. This conversion, all of you are able to understand? Tanmay? Shubhangi?
Yes, sir.
Yes. Aditi?
Yes, sir. Yes, sir.
Okay. So if you are able to understand, it is a good thing. So this conversion, you should be able to do that after. So after execution, what you will be getting? You can see I'm having the arrow right now. So you can see 0 1 is the input condition. So for that 0 is the output. 1 1 is the you can say both the inputs are on. Then in that case 1 will be there. That is output will be 1. Then again 0 1 is there. For that 0 is the output. See, these are two different things. Uh, Rules for addition subtraction is a different thing, and logic operation is a different thing. Otherwise, what you could have understood in a different way means you could have obtained different output. That is, suppose Suppose you are doing normal functioning, then 0 plus 1 becomes 1. 1 plus 1 becomes 0 plus carry 1. So like that it happens, 0 plus 1 again becomes 1. But this is a logical get operation. So that is why both the inputs are on, then only you will be getting the output. So this is how what happens, and you will get 0A is the final output. That 0A will remain in the accumulator. Then you can access the accumulator to see the output. Then similar thing is there, that is before execution. Then say memory location 2050 they have taken. So for that accumulator is containing 55. There is B3 is another content at the memory location. So for that you will be getting some output. Again you will carry out AND operation, and then finally 11 is the outcome that you are getting. So this is how AND operation will be carried out. Then a slight modification into that instruction, that is you can have ANI instruction. It means logically and immediate with accumulator. The contents of accumulator are logically ANDed with 8-bit data. The result is placed in the accumulator. So example,
Hello, sir.
yes, who is there?
Could you go to the previous slide and explain the addition and the conversion again?
Addition.
So the addition logic and the conversion, can you explain that again?
Okay, I will take the this one slide, na.
Yes, sir. Yes.
So say example is, suppose memory location is there, 2050 is the memory location. For that some number is there, that is B3. Accumulator is containing 55. You are carrying out AND operation to this. Means you are logically ANDing the contents of memory location with that of the accumulator. So 55
So
you
not
will convert into the
so sorry to interrupt, not this conversion, the one on top, the 0F and the AA conversion.
the truth table.
No, so the conversion of AA and the conversion of 0F.
Okay, that conversion you are not able to get.
Yes.
Okay, fine. See here, suppose I will take a quickly simple example. Suppose you want to convert 0F. Okay, so there should not be much problem as far as 0 is concerned. So 0 will be like this. All four zeros will be there because there is nothing that you want to do. Now the simplest thing you can do for F, that is 15. Number you want the number 15 hexadecimal system. Last time what I told you, you can start from here. Okay, you can have 2 raised to 3. Two raised to 3 you can have. So this will be 2 raised to 3 plus 0 into into 2 raised to 2. This will be 2 raised to 2. That 2 raised to, I'm not getting that. So I'm just mentioning over here. This is 0 into 0 into 2 raised to 1. Okay. And this is after that 0 into 2 raised to 0. Okay. So in this particular case, since all zeros are there, you will be getting the answer as 0. If you want a 15 number, so how will you get that 15 number? You can just, for example, you can just write down four zeros. Now I want 15. So obviously this has to be 1. If I take this as 1, means 2 raised to 0 into 1. So it becomes 1. Then suppose I take here again 1. Then this will be 2 raised to 1. So 2 raised to 1 is 2 into 1. It becomes 2. 2 plus 1, previous one. So it has become 3. I want 15. So now I will take this again 1. So this will be 2 raised to 2 into 1. 2 raised to 2 is 4. 4 plus earlier 3. So it has become 7. Now this 0 will also, I will take it as 1. So it will be 1 into 2 raised to 3. 2 raised to 3 is 8. 8 plus previous 7. So it will become 15. So to get 15, you will have to be all ones. If A is there, so A is the 10. Now you are familiar with this. So you can just manipulate things. This A you can take it very fast. You can have just 2 raised to 3, that is 8. And you want 2. So 2 will be the last but one. So you can have 1 0 1 0. Then you will be having 10. Got it, Aditi?
Yes, sir. Thank you.
So, so it is that simple. 2 raised to, you can always start from it is called actually LSB, MSB. From the right side, you can start 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. That's all. We are not moving ahead than that because it is a 8-bit microprocessor. Again, the similar thing when you will be actually solving the problems, that time again we will discuss this. So this is ANI instruction. So this ANI instruction means what? You will directly add the 8-bit data with the content of accumulator. So here 8-bit data can be anything. So here they have taken the example of 3F, and then accumulator is containing B3, convert into the binary, apply the AND logic, and then you are getting it. Similarly, the instruction is there for or carrying out or. Or is a very simple thing. Or means you are familiar with the either or. So that either or means either of the input is on, you will be getting the output. So that truth table last time what I have suggested, it changes over there. So what will happen in this truth table? This will become 1. This will also become 1, like that. Any of the input is 1, you will be getting the output. So this OR logic you are applying over here. So it will become something like this. That is A accumulator is containing double A, B is containing 12. You are carrying out OR operation. As per OR logic, you will be getting the output. Similarly, OR M you can have. Similarly, OR immediate. Like you're done for the AND immediate. So here OR immediate also you can carry out that operation. Okay. So I think we can stop here for today. And up to this much will be there for your MST syllabus. I will upload this slide immediately on the classroom. If any other slide you people require, I will upload that also. Okay. So I'm just putting over there the link. You can just mention your attendance and then you can leave. So the link is there. You can just mention your attendance. So I think all your doubts regarding the MST have been answered. If any doubt is still there for MST, you can just ask me right now. Later on, also you can put it over there in the WhatsApp. No issue. Okay. So just mention your attendance and then you can leave.